All right, number 15, we want to approximate the change in the volume of a sphere when the radius changes from r equals 40 to r equals 40.1. So this is the other formula that we saw. Change in y is equal to f prime of a times the change in x, or delta x. And you might see in the text dy, and they might call this dx. Similar, but all we need to do is find the derivative and then multiply it times the difference in the two x values. So our volume function v of r is 4 over 3 pi r cubed. We're going to find the derivative. Multiply by the power of 3. It will cancel out with division of 3, leaving me with a 4. Pi is a constant, and then r squared. Okay, so here's my derivative. We're going to multiply this times the difference. In this case, we went from 40 to 40.1, so we increased by 0.1, so the difference is going to be times 0.1. All right, and then all we're going to do is plug in our initial value, which was 40. It's going to be 4 pi 40 squared times 0.1. The computer says type exact answer, so I'm going to type all of this in, leave it as pi, and then I'll add the pi at the end. We don't want to round with pi. So we're going to do 4 times 40 squared times 0.1. 40 squared and 0.1. And we get 640. And so we just tack on the pi, and that'll give us the exact answer. All right, number 16, we want to approximate the change in the lateral surface area. Right clone, it says a fixed height of 6 when the radius decreases from 12 to 0.9. So same type of problem, just a different function. So we're doing surface area S equals, say, pi r times the square root of r squared. It said h was fixed, so I'm going to go ahead and put 6 squared, or just write it as 36. So here's my function. We're going to find the derivative. Product rule, 1d2 plus 2d1, so 1, first term with r, 1 d2 derivative. Using the power rule, this is 1/2, so 1/2 times r squared plus 36 raised to the negative 1/2. This is the power rule, then the chain rule, because you got to do the derivative of the outside times inside, so it's going to be times another 2r. So this is 1d2 plus 2, sorry, not 2, the second function, r squared plus 36, 2, derivative of the first is going to be, that'll just be 1, so it'll just be times pi. All right, so this is the derivative. The change went from 12 to 11.9, so it decreased by 0.1. So all of this is going to get multiplied by negative 0.1 to show that decrease. We're going to plug in the initial value for r, which was 12. Try to simplify some of this. So 2.5 will cancel out. r times r will give me r squared. So s prime of, I guess, 12 is going to be 12, and I'm doing r times r, so it'll be 12 squared times pi, and then all of this is going to go to the bottom, so it'll be over the square root of 12 squared plus 36. All right, so this is the first part, and then over here we won't do anything except for replace the r squared with 12 squared plus 36 times pi, and then all of this is getting multiplied times a negative 0.1. And then we'll simplify one more small step, because again, I think we want exact answer, so I'm not going to simplify these square roots. 144 and 36 gives us square root of 180, and so I'll write 144 pi divided by the square root of 180 plus pi times the square root of 180. So that's simplifying this part. And then all of this is times negative 0.1. All right, so that'll give us the exact answer if we were to type that into a calculator. 144 pi over square root of 180 plus pi square root of 180 and then times negative 0.1. It looks like a minus. Yep, I need to do this as a times. Figured it was going to read that as a minus.